Sometimes a wave is going to travel from one medium to another. Like in this case here, the wave is going to start in what we call a light rope, and is going to move to a second medium where we have a heavy rope. Now, light rope, it means the mass per unit length, or mu, is smaller than mu for here, the mass per unit length. Okay, let's start, for example, with a pulse. You see here it's a crest. It's moving towards the heavy rope. As it meets the interface here, part of it is going to be reflected, like here, and part of it is going to be transmitted. Notice that the reflected part is inverted. We started with a crest, and we got a trough. However, the transmitted one stays upright. We started with a crest, we get a crest. On the other hand, when we start with a pulse on the heavy side, so it's coming here, it meets the interface here, the transmitted is still in the same orientation. It's still upright. However, the reflected is also upright. I started with a crest and I got a crest. See the distinction here. When we went from light to heavy, reflected is flipped. When we go from heavy to light, reflected stays upright, stays in the same orientation. The transmitted in both cases stays in the same orientation. The key, though, of what we mean by light rope and heavy rope, the wave moves faster in the light rope than in the heavy rope. The key is not the mass per unit length, the key is the speed of the wave. When the wave moves fast in a medium and meets a medium where it's going to move slower, the reflected one, the reflected wave, is going to be inverted. Now, a couple of things to pay attention to. Whenever there is an interface, like here, part of the wave will be transmitted, the rest is going to reflect it. That's energy conservation. So part of the energy is going to move on, and part of it is going to be reflected. Now let's look at this in terms of a video. Okay, fast medium, look at the pulse, triangular pulse in this case, look at the reflected. It is inverted. Look at the transmitted, it is upright. Okay, now we are starting at a slow to fast. The reflected is still upright. The transmitted is still upright. Let me redo it. Fast to slow. Look at the reflected is inverted, transmitted upright. The other one is going to be a little faster. Moving slow, faster. Look at the reflected. The transmitted also is moved quite fast, but in the upright orientation. Let's see this real life. Okay, the wave here moves fast in this slinky, and this is some other type of spring that we call snaky. So it moves slower here than here. And look at it. Okay, see how it's moving slower. The pulse starts at the bottom here and then continues at the bottom. So the transmitted is not inverted. We go from fast to slow. The transmitted is not inverted. Okay, now pay attention at the reflected one. So once the wave is going to meet here, part of it is going to be transmitted, part of it is going to be reflected. Okay, look at the reflected is upright. Okay, look at it. Okay. Now let's see another example. Okay, so here we are starting with a slinky where the wave moves slow, and it goes to a different slinky where it moves fast. Okay, let me repeat the video. Okay, Pay attention, the pulse is starting here to the right of this individual. So it starts in a slow medium, in a slow slinky, and it goes into a plastic slinky where it moves faster. Notice, pay attention to the transmitted one. It should remain in the same side of the pulse, so it should remain in here. And the reflected one, since we go from slow to fast, you'll also notice that the reflected is in the same orientation. Okay, look, reflected is same orientation. Transmitted is same orientation. It's fast, but same orientation. Okay. Now we have the opposite. So we start with a pulse here. Transmitted in the same orientation, reflected is inverted.